Hello and good morning everybody. Welcome you to this webinar straight from here, from the Prime Software Academy at Augsburg. My name is Roland Pott. I'm technical instructor here and I have some experts with me. Number one is Dr. Matthias Schlipf. He is the project manager of the MAN 175D, and we will talk about the engine. And the second, today our important guy, is Andreas Döring. He is the head of the aftertreatment technology at MAN Diesel and Turbo. Few words about our company. Many of you know us. MAN Diesel and Turbos building engines from 475 kilowatt up to 89 megawatt, constructing power plants, and with the help from our friends from Oberhausen, make gas turbines, steam turbines, and many, many more things. MAN Diesel and Turbo is also a member of MAN Group, and we have the sisters from MAN Truck and Bus. So, our new product, the MAN 175D, is to be covered with all these webcasts. This is our first webcast, and I'd like to hand over to Matthias to tell us something about the engine.
Well, first I'd love to tell you why do we do those webinars actually. We had the pleasure during the past 3 to 4 years to visit numerous customers, operators, shipyards, design offices, and we learned a lot. And those become partners now. What we want to do now with the webinar is threefold. On the one hand, keep the contact with our partners, with our advisors. On the second hand, keep them updated with the latest information about our engine, around the engine, and just interesting topics. And the third one, do this in a decent and attractive way. Not sending out now hundreds of brochures or documents, but just offer a live webinar every 3 months. If the time suits you, if the content suits you, just log in, or you can also download this from our homepage. But do this really in a very simple and pragmatic way.
Thank you. The surroundings of this webinar, we plan 25 minutes, so roughly 20 minutes presentation or interactive media, and then we have time for a question and answer session. So this is our invitation. Please write questions, please write comments. On the screen you will see the window where you can enter questions and they will pop up here. I cannot guarantee that we will answer every question in this webcast, but we have social media sites and there you get all the answers, and later on our micro page you will find the answers to your questions. So, Matthias, would you please tell us something about the engine in general? As you can see on the slides, we have some main topics for the engine.
Exactly. As you can see here, those are our key statements, key characteristics which we learned during our customer visits and which really from the start of the development 3 years ago we put into realization. This means to put up a clear and compact engine, meaning easy access to the service parts, easy maintainability, simple commissioning, clear sides, clear ends, and to have this in the most compact format. So what we offer you from power to size is the benchmark in this industry. Advanced and robust, meaning we have the highest peak firing pressure, which we translate on the one hand into robustness, on the other hand our, I would say, really key statement, efficiency. We want to serve you to have the most efficient engine that is out there. And for life cycles that you have 10 years, 20 years, even more, this is really where you get your value back. Clean, this is the topic which we really talk in detail today about. Clean meaning fulfilling all the emission requirements that are out there in the world. Maybe a few more words to the engine. We have our own turbocharger system, own electronics. We have an advanced common rail system and a lot of different options giving you flexibility, meaning free PTOs, especially important for the commercial marine market, but also flexibility, 100% power takeoff at both ends of the engine, so you can turn it, and other intelligent features. When coming to the value proposition for our customers, this is quite simple. If required, we offer you the complete system, the complete propulsion train, starting from the propellers over the gearboxes to the engine and ending up with the exhaust. And exactly the exhaust system, this is where we want to focus today about, because it is just a burning topic. I mean, IMO Tier 3 is there, US EPA Tier 4 as well. And we designed in a very modular and flexible way an SCR after-treatment system that will fulfill all emission regulations that we have currently. And this is where my dear colleague Andreas comes into the game. Andreas, it's up to you. In the bit, what did we develop?
Okay, thank you very much, Matthias, and also a very warm welcome from my side. So, many may wonder, why do we start this webcast series with a after-treatment system and the exhaust gas after-treatment system? Yeah, like Matthias already mentioned, it's a burning issue, and all our customers, they asked us, how do you fulfill the upcoming emission limits? And like shown here on the first slide, there are these NECA areas taking place into 2016 on. But you not only have to focus on the NECA zone that is established in the US and the Canadian coastlines, you also have to focus on the local regulations, the harbor regulations, national regulations. And this gives a great uncertainty into the market, and the 175D and its after-treatment system has to fulfill these requirements. So, like Matthias already mentioned, before we started, we had this blank sheet of paper asking us, what do we put on this paper? So we visited our customers. We asked them, what are the key factors and the key topics we have to focus on? And we asked yards, we asked the end customers, we asked the people from the truck boat industry, and all these people, they had different priorities, but it boiled down to three major topics everybody is concerned of and everybody asked us to take care of. The first topic is maximum flexibility, saying flexibility regarding emissions. So nobody wants to be limited to not sail into special areas of the world because the ship doesn't fulfill the local requirements. And the second thing is, everybody understood that you have to put something onto the vessel to fulfill these requirements, but nobody really wants to change the design of the engine of the ship, or wants to have special requirements regarding pipe routing or whatever. So the second is robust and reliability. Like Matthias already mentioned, that's one of the key values we have to take care of. The system has to be robust and reliable. And up to now in the marine market, there are some SCR systems that are not robust and reliable. So we focus on this, and it's a very important issue. And the last thing, that's always the case in this marine business and also in commercial and all the markets, they take care of TCOs, so total cost of ownership has to be reduced and has to be kept at a minimum. So how did we approach this issue? We, like Roland already mentioned, there's a close collaboration with our sister company, it's MAN Truck and Bus. And at MAN Truck and Bus, they developed SCR systems for the Euro 5 and the Euro 6 legislations. And up to now, they have sold already 300,000 units with roughly 55 billion kilometers on the road. And here at MAN Diesel and Turbo, we put power plants and marine applications into service with roughly 800 megawatts and 200,000 operating hours. So we combined these two systems to come up with a combined and compact and reliable system I'm going to show you now. So let's just, before we start with the special 175D after treatment system, I will give you a short introduction into the SCR technology. SCR means that you decompose nitrogen oxides by using ammonia. This takes place at this so-called SCR catalyst. Ammonia is a toxic material, so we don't use ammonia, we use urea. And this urea will be injected in the exhaust pipe, and it decomposes to form ammonia, and this ammonia is used to decompose nitrogen oxides. So that's a standard solution you can see here, standard setup of an SCR system. But what's important is you are somehow limited regarding pipe lengths and where to position the reactor, because you have to keep a certain length of the mixing pipes to get a proper mixing between the urea and the exhaust gas. So this was not our focus for this 175D because, like I already mentioned, our customers asked for high flexibility regarding mounting and positioning of the SCR catalyst. So when it comes to SCR technology, the main problem with SCR technology is you have to introduce the urea in a way that you do not form any deposits. These are some disaster pictures from our earlier experiments where you can see that if you don't do it in the proper way, you may block your exhaust pipe, and this may even stall your engine. So the solution at MAN Truck and Bus, our colleagues from Munich, for this problem is they use an engine-mounted ammonia generator. And at this ammonia generator, you decompose the introduced urea and form ammonia. And from downstream of this ammonia generator, you don't have any problems regarding piping or deposits or whatsoever. So here you can see the Euro 5 solution from MAN Truck and Bus, where the SCR system has been introduced into the truck business. The important thing about this slide is that there's the ammonia generator very close to the engine, so engine mounted. And the SCR catalysts are mounted in a standard muffler, so it was not necessary to enlarge the space needed for the after-treatment system. We just put the after-treatment system in the existing muffler. And that's the same idea and the same concept we use here for this 175D after-treatment system. What's important on this slide is for this 175D, we eliminated the compressed air supply that's mostly needed for proper spray, to get a proper spray. So this could be eliminated. So what about this 175D after treatment system? Like already mentioned, we split up the system. One part of the system is engine mounted, so it's a very integrated system. And the second part is the SCR catalyst. And by doing so, you are no longer limited to a certain pipe routing or how to orientate your SCR catalyst. You are completely free. You can put the SCR catalyst wherever you want. And further benefits are, like already mentioned, there's no longer a compressed air supply needed. And they have a patented feedback control. This lowers the urea consumption and also prevents ammonia slip. And what's also important is that the development is focused on substituting the existing muffler with an SCR muffler. So we introduce sound attenuation into this system. So, but that's not all. We give you far more freedom. We designed two different reactors. One reactor that's called the cube design. That's a design where you have minimum width and less effort on piping. But if you're somehow restricted to height, there's a second reactor that is very narrow and you can put it everywhere you want. Okay, so we prepared a short movie with animations showing you where and how to put the after-treatment system on a vessel. Like already mentioned, we looked at yachts, naval and governmental applications, and commercial vessels. So the first example, that's a yacht example. Like Matthias already mentioned, you can get the whole system from a propulsion crane over the engine to the after treatment system. From governmental applications, the SCR system has been put in the funnel. And for the commercial marine applications, that's a different design and a different location. And here it's beside the engine and no longer inside the funnel. As this is an important topic and makes this system unique, I'll go into detail about this different opportunities you as the customer have to position and locate the SCR mufflers. So first, let's take a look at the Navy patrol boat with a 12V 170D, 175D engine. Here the SCR containers or mufflers are located inside the funnel. Here it's a picture of the exhaust piping and the SCR catalyst. Another example, the yacht, where the SCR catalysts are very close to the engine, and I think here it's very clear that there's not a long mixing pipe and a proper way to decompose urea. So here this is a great advantage of our system. The SCR catalysts are right beside the engine and the exhaust outlet is below the waterline. The last example I would like to show you is the tugboat. For the tugboat, it was far more difficult than for the other engines and for the other vessels. So one example would be to place the SCR catalyst and the SCR muffler besides the engine, and you can have different options. You can combine the piping from the engine to one, or you use two. That's here, but one interesting topic point about this different SCR reactor designs can be shown here. There the SCR reactors are placed right beside the ceiling, so put on the ceiling. Like here, you have this cube design on the ceiling, but if you don't have enough height in your machine room, it's possible to change this and use the blade design of the SCR mufflers. So, let's come to the conclusion. So, the 175D engine will be equipped with the patented and reliable and proven MAN AdBlue technology. Like already mentioned, 300,000 units sold up to now. The muffler will be replaced by the SCR reactor, so sound attenuation is included, and in most applications no special silencer is needed to reduce the noise limits to the limits we have to fulfill regarding SOLAS. It's a modular system that gives you maximum flexibility regarding piping and orientation of the SCR reactor. The system can be operated on DMA, and the NOx conversion is up to 97%. This gives us the opportunity of SFOC optimized engines, so TCO benefit. And the air supply is no longer needed for urea injection, so another important topic to reduce the total cost of ownership. So, thank you very much for your attention, and we are gladly answer your questions now.
Thank you, Andreas. As named in the introduction to this webinar, you are allowed to ask questions. The first question already we have on the screen. First question is, please advise some key considerations for SCR over EGR systems to meet NOx regulations.
That's a very important question, very good questions. like already mentioned in the beginning, we visited our customers and they asked us, we asked what are the key values and the key components and the key topics we have to focus on. And one of the key topics, like already mentioned, is the lowest total cost of ownership. So meaning that the system has to run, for example, on DMA. And if you run on DMA with high sulfur levels, it's very difficult to develop an EGR system, because then you run into serious corrosion problems on the engine and on the coolers and whatsoever. So we have chosen a robust and reliable solution, and that's the SCR technology.
Thank you. The next question. Are there any performance trends for the SCR system during engine accelerations, like slowdown? Or are there special tasks for high dynamic variable workload conditions, tugboats and so on?
Yeah. Okay, that's also a question that has often been raised. And like mentioned already, we developed this system together with our colleagues from MAN Truck and Bus. So the system is originating from the truck and vehicle applications. So there the load variance and the dynamic behavior of the engine and the exhaust system is very, very transient. So we took this, this knowledge and this experience and integrated it in our system.
Thank you.
Maybe to add just a few words, what Andrea said is exactly right. Because you have to imagine MAN Truck and Bus, you have a truck running over the highways for hours and days. And there you have really always the same load, but in a permanent matter, which could you compare to a ferry operation, offshore service and supply. On the other hand, buses running in the city traffics, this is an ongoing stop and go. Also a lot of idle mode. This is exactly what we see in the tugboat or the workboat business. Therefore, we're very optimistic actually, taking this system from our sister company and really transfer this to the needs we have in diverse marine applications for the MAN 175D.
Exactly.
Thank you for this addition. The next question. Please explain some more on the split exhaust gas piping. That looks like more work.
Yeah, that's true. From the first glance, it looks like more work, but I think this question correlates to this slide. You also have the opportunity to combine the exhaust gas piping, like mentioned here. Here you have this 2 exhaust lines feeding 2 SCR reactors, and you can also combine this to 1. It's no problem.
Thank you. The next question, I guess everybody wants to know this. Are there issues, or what is the maximum allowed back pressure on the system?
Up to now, the maximum allowed back pressure is 170 and 155 millibars.
155 millibars?
Yeah.
Okay, thank you.
So that's the allowed back pressure. The actual back pressure is far lower, so this gives the customer the opportunity to add some more components like boilers or whatsoever.
This is perfect, leading to the next question. Thank you again for this question. Which is the expected noise reduction of the reactor installing along the exhaust gas system? Do I need additional silencers or something?
Yeah. Oh, yeah. It's a very good question. The answer for this is that we developed the system to fulfill the Solar's requirements. So this meaning 78 dBA at the exhaust pipe outlet.
Thank you. And I think this is the last question. There's a question for more detailed explanation of the ammonia generation from the urea.
The urea is introduced into a special generator. It's a catalytic generator, so it's coated, and we keep the temperature at this generator very high. And at this generator, the urea completely decomposes to ammonia and CO2. So you don't get any deposits on this generator.
Thank you for this. Thank you everybody for joining us in this webcast. The webcast will finish here. We will put a video on our microsite. Please ask more questions. They would be answered via the social networks like Facebook and so on. And we would be happy if you join us the next time on the next webcast, end of June.
Exactly.
with a different theme.
And the different theme will be actually the design philosophy behind the engine, and how we put the design philosophy really into reality for all the different applications which Andreas mentioned, with the same flexibility and modularity as we hope to have proven you with the SCR system. So thanks a lot from our side.